Hello everyone, my name is Prathamesh Karamkar. I think we had introductions already. I'm given difficult task of uh, people, keeping people away from food, so I'm gonna try my best. I know everyone is hungry, but yeah, and the counter started as well. Great. Okay, in this talk, what I'm gonna talk about is ALAP. So it's an acronym actually, which stands for AI Assistant for Legal and Paralegal Functions in India. But before we go there, sorry, may I have the slide changer, please? Here. No. Okay. Before we get into that, what I wanted to talk was about. This is when we talk about like how or when to fine tune, right? So we hear these words flying around, right? Whenever you see that, hey, my response is not great from any AI assistant, let's fine tune, right? So what in this talk we're going to take this case study, this particular case study. But before we go into that, in general, advices from my personal experiences about when to fine tune, when not to fine tune, whether it's worth investing into that, what are the learnings from the whole of the things that we did while building ALAP. And if I had to recreate it again today, because we did this around a year back, if I had to recreate this today, how would I do it? Right. So we hear, like I was saying, like we hear people saying that, hey, maybe responses from OpenAI models is not up to the mark for my task. It doesn't understand what I'm doing. Prompting is not helping. Can I fine tune? I want to improve this performance on my task. I want to give it my context. Should I fine tune? I'm not happy with the kind of latency I'm getting. I'm getting answers, let's say in 15 seconds, 30 seconds. Should I fine tune? I'm my OpenAI, like my credit card bill for LLMs is going out of hand, running me thousands of dollars in a month. Should I fine tune? I'm having some issues with security. I'm not getting security clearances for the state of the art models that just were launched last month. They are giving me the best of the performance, but they are not up to the mark. Should I fine tune? So those are the kind of common questions that we get from our clients, like on a daily basis, right? And then it depends, right? It depends on multiple things. So what I'm going to talk about is, in general, this is a screen grab from Andrej Karpathy. Do you guys know him? Have you heard of him? Andrej Karpathy, who co-founded OpenAI, now not with OpenAI, but he's a great scientist who working on this. It's a screen grab from him from the talk that he gave State of Art GPT at Microsoft Build around 1 year back, still very relevant. So these are what you see on the screen are like the 4 steps that you see while building any, in general, GPT kind of assistant, right? So the first step is pre-training that none of us here would be dealing with because it's very expensive. Pre-training is out of scope for most of us. The next step comes supervised fine-tuning, right? And a lot of people actually do this for this. When we did this in ALAP, right? And that's what we had to talk about. Then the third step is reward modeling. And then there is reinforcement learning, right? The last two are kind of related. I mean, they have to be done together. But people here, do you know reinforcement learning? How many of you know reinforcement learning? Reinforcement, nice. Okay, yeah. So reinforcement learning is kind of how is it? It's a branch of machine learning which deals with like training a reward model. It's like an agent-based approach, essentially. But again, like agent does something, and then you give a reward to it, whether it's right, wrong, and then based on that, you kind of evolve the process, right? And most of the most advanced models, the state-of-the-art models, have done all of these, right? So the key thing to understand here is if you look at the each state, it's important to notice the amount of data set that's really needed, right? So a couple of takeaways from here. Even if I want to do supervised fine tuning, the rough estimate is few tens of thousands of data points. And when I say data point, what is a data point? A data point is like you give some instructions and then you get some response, right? That becomes a one data point for me. So even if it's very long, it's a like 10-page long instruction and a 1-page long output, still that becomes one data point. Likewise, you need to have tens of thousands of pair to be able to meaningfully do any fine tuning, right? It's very hard to do this. Let's say I have few tens of examples and hundreds of examples. It's really difficult or not worthwhile to take on this path, right? So where you start? So when you go from left to right, these are the process that you will. So you do first pre-training, then you do a fine tuning, then you do a reward modeling, and then URL, right? So mostly people will start with a pre-trained model, right? Like you have like Llama 2, Llama 3 kind of models that are available with open source weights, right? I mean, licensing is a different thing, but to be able to do fine tuning, you need to have an access to a model which has open weights at least, so that you can change. So when people refer to fine tuning, they mean different things. When in technical terms, when you say fine tuning, or like you should say supervised fine tuning, but people don't use that term. People just say fine tune. It actually refers to taking a model and changing the weights of those neural network, or changing weights of some of the layers that is present inside those. And that's the actual meaning of fine tuning. People loosely sometimes say that I'm just fine tuning on my data. By that, what they mean typically is like, okay, I have a RAG, I retrieve the right information, put in the prompt and get my answer. That's not fine tuning. Fine tuning actually refers where you're actually changing the model weights for your specific purpose, right? So just like a terminology establishing. And then you have reward modeling and reinforcement learning. So you start with a supervised fine tuning model, try to include human preferences, right? So if I take a super fine tuned model, I give it some kind of questions, I get some answers, right? How do I incorporate human feedback that whether I prefer this one, that one, or none of this? If not one of those, what should be the correct output, right? So incorporating the human feedback in this training process is what we have in the reinforcement learning thing. So there are now new techniques which kind of don't necessarily do reward modeling and reinforcement learning both as a separate step. So it's called as DPO. It's a recent technique that has come up. So where you don't need to necessarily have training of the reward modeling. And then there is also like a PPO method, which kind of needs to do explicit reward model, explicit RL, including that, right? So we'll not go in the details of those, but just wanted to keep you in mind that this is what really is the training pipeline, right? And based on what I have gathered working in this field for like past 1 to 1.5 years, this is a recommended approach for developing LLM apps, right? And this is not a global solution which will solve all the problems, but maybe, I hope that maybe works in 90% of the cases, which is good enough for us for practical purposes, right? So what are these three things, right? So first is having evaluation framework. I think we spoke about it. I think Sarang spoke about it. Bernie Vanya spoke about it. I'm not going to talk about evaluation framework, but just the thing that I want to highlight here is we need to have an objective evaluation framework. What that really means is, can I say that, hey, I want to build a chatbot that answers my 90% of my customer questions under 5 seconds, right? Does this sentence qualify to be as a good evaluation framework on its own? Maybe not, right? It's clearly not, right? Because the evaluation framework clearly has your evaluation metric. It needs to have evaluation data, right? So as Sarang was saying, that get the kind of questions, the representative sample of what this app is supposed to happen, right? Then have a ground truth for that, and then have a evaluation metric. Like, okay, compared to this ground truth, this is what I expect, right? So it's very important. I mean, a lot of people start without having an evaluation framework, and they say, hey, we'll take it as it comes. We'll see. Let's see what happens, right? But that becomes a pitfall here that should be avoided, right? Then the next step is achieving the best possible performance, and then after that you optimize, right? And there is a difference why you have to do it sequentially. If you can't get to the right performance, there's no point in optimization, right? And when we teach ML or when we learn ML, it's a similar story, that you first take a model, you do so much training on that so that it overfits, and then you regularize. Similarly, here in this case, you first achieve the best possible performance that is available with the tools that are existing, and then you try to do an optimization, maybe in terms of cost or in terms of latency, right? So it's important to understand that achieving the best possible performance comes first before doing an optimization, right? Doing it, okay, I want to directly optimize my app. Okay, it should give me an answer of below 5 seconds. Maybe, I mean, that's not the best approach, right? I mean, that's your eventual goal, sure. But then to be able to understand the trade-off of accuracy versus runtime, you need to first see what is possible, what is the best possible, right? And again, like coming back to the question, right? Should I, if I have some problems, pressing problems, should I, is fine-tuning a direct answer to that? And this slide, the three things that you see here, these are kind of like first things that you should try before fine-tuning, right? So fine-tuning is coming here when you're developing custom models, right? So there are two blocks here that will solve 99.99% of your problem. And if the ones that are left over, then you should try to think about custom models. So even this talk is about how to fine-tune. The question really is whether you should fine-tune, right? That becomes a central question, right? So first thing to try is prompting, right? And as we heard in the keynote speaker from Bernie, that prompting is underrated, right? We feel that, hey, prompting, okay, fine, what, just writing prompts, right? But there's so many things in prompting that you can do that can give you a nice starting point, right? And what are those, right? So you always start with of this state-of-the-art model, and you look at the benchmarks that are closest to your task. So for example, I am building a chatbot that needs to query my database, right? It's a natural language interface over data, which needs access to data which is stored in SQL. Then I need to look at a benchmark like BIRD. BIRD is an acronym that stands for a benchmark, which precisely does this, right? So you to look at that benchmark and see what's available, what is the performance of various techniques and models on that benchmark, and use that as a starting point, right? So rather than reinventing all the things yourself, that becomes a very good starting point, right? And then using RAG, I think very, very relevant. I think we spoke a lot about it, so I'm not going to talk about it more. Adding few short examples again is something that that helps the model immensely, right? Because there's one thing, like you can explain up to a point, but once you start giving examples to the model, it really shines, right? And we have seen this multiple places. When you actually give examples, the model starts learning. Then there is the last point about writing automated prompts, right? So how many of you have done prompt engineering here? Prompt engineering, yeah. So this prompt engineering is soon going to get automated, right? How is like now we have humans writing prompts. If you follow the right methodology, you will have AI writing prompts and optimizing it, right? And there are frameworks available for it. The most popular one is called as DSPY. That's what I've given here. So you basically automate the process of prompt writing, right? So how do I do prompt engineering? Okay, I go write prompts, look at the results. It doesn't work. Okay, try something else. Change this word, change that word, change the example here, right? So think of it as like in traditional machine learning, you're developing, let's say, a decision tree or a linear regression, and you're trying to set the parameters of linear regression by hand, right? Do you do that? No. Who does that for you? There is a process, right? Like there are optimization techniques that do it for you, right? Similarly, in LLM world, this can be automated with help of these automated prompt writing techniques like DSPY. So once the prompting is over, then you should try to go for agentic ways of exploration. So I think I'm not going to talk in detail about agentic approaches because we heard from in the previous talk about what are these agentic patterns. There are 4 of them. Not all of them are going to be relevant for your specific problem. You need to understand which one is relevant. But reflection, and then tool use and planning, these are the most common ones that we feel like can solve a lot of problems. And again, like multi-agent collaboration is again an evolving field. Your application may or may not need that, but if it's reaching to that point, maybe it's worth giving a try. If you're here, you tried agentic approaches and still you feel that no, performance is not there, right? Then it's the time to think about, hey, can I do custom model? Not before this, right? What people do is, okay, prompting not working, let's fine tune, right? I mean, that's not the right way, right? There is so much that you can do with existing models. You need to try that before you try the custom models way, right? And then again, in custom models, you have supervised fine tuning, and we saw there are model alignment with human feedback using DPO and PPO kind of techniques that we discussed, right? So let's say now I'm at the end of step 2, I got a solution that has a nice accuracy that I feel that, okay, it's nice, but hey, it gives me, like it takes 30 seconds to respond. What do I do, right? It's just too long. Then comes like, how can you optimize, right? And the first thing there to try is like, really, can you do a trade-off there in terms of accuracy versus the kind of the latency essentially, right? So if I take 4.0 and I've swiped it out with 4.0 mini, how much degradation is happening, right? If it's going from 95% to 94%, just live with that, right? Anyways, because it's critical, the shipping time becomes important, latency becomes important, right? So it's very important to understand, and that's why the evaluation frameworks is important, is to have the right evaluation framework to do these kind of trade-offs, right? And also that like you can fine tune the language model for specific tasks, right? So a lot of time people when they're building an entry point into a chatbot, there is an intent classifier, right? And what does user want to do? What is his intent? Out of these 5 steps that I can do, which one of it is really trying to do? It's a simple classification technique, right? This is the question. Tell me, out of these 5 classes, which one it classifies under, right? You don't necessarily need a billion or hundreds of billions parameter model to do this kind of intent classification. It may be easier to get started off it, but there is a chance that you can use smaller models and do this. I've been doing NLP for 10 years. I've built these models with more than 90% of accuracy, starting with keyword based, then later with BERT, and now with smaller models, right? So there are steps involved in the workflow that can be solved with a smaller optimized model and doesn't need kind of a bigger model, right? Right. So having heard all of this, we'll come to ALAP, right? So ALAP is an acronym, as we said, for AI Assistant for Legal and Paralegal Functions in India. So why did we build this fine-tuned model in first place, right? So we all heard this story about the New York District Court lawyers, where the judge had to fine them for generating fake citations, right? Fake citations is like, whenever I'm putting forward an argument, I need to back it up with an old judgment that came from a higher court and saying that this is the principle that was established in that case, that principle applies to my case, and hence I'm putting forward this argument, right? Now, lawyers, being very smart and want to be more efficient, two lawyers from New York District Court used ChatGPT. Hey, that these are facts, just generate some arguments, right? And then LLM happily generated them, and it was caught. And yeah, I mean, they refined it. So it's more than like, it's a reputation loss for lawyers, right? So that's a big pitfall to avoid. Then using of Indian laws and regulations, right? If I'm sitting here in Bangalore, if I want to construct a house, I don't care what happens in US, right? I want to know what are the bylaws here, what is the FSI that I can consume, whether I can build this balcony, right? And so that law may be present somewhere, written somewhere in Kannada, that I can't even understand, and in the form of some OCR. Maybe I have to go and visit maybe BMT's, the Bangalore Municipal Corporation to get that copy, right? So I want an LLM that can understand Indian context, right? Then the need of using frameworks like IRAC. So IRAC is a kind of a framework that they teach you in law school in first year, that when you want to put forth an argument, how do you put forth an argument, right? So first step is to identifying of the issue, that's a legal issue at hand, what law applies in that, applications, like how does that law apply in this particular situation, and then put forward a conclusion, right? So the need was, hey, can you when you talk to a lawyer or when you talk to a judge, it's a common understanding that you need to follow this kind of framework, right? So we wanted to teach the model this kind of framework. And then understanding of legalese was another driving force. So at that point of time, we felt that most of these problems could be solved by doing fine tuning, and we jumped the gun. I mean, we'll come to it later, but when looking back, maybe some of these problems can be solved, right? So for example, retrieving of the law should be fairly simple. If I put an IRAC in prompt, the LLM does understand it actually. So we'll come to that, but these were the driving forces that led us to believe that, hey, if I do fine tuning, maybe we'll get the right performance lift that we're looking for. So the next step was, hey, now okay, fine. We want to do fine tuning, but fine tune on what? What do you want to achieve, right? So then we spoke to a lot of lawyers, law firms, judges, faculties from law schools, and then tried to and ask them a question: if you want to automate certain tasks in your daily lives, which are those that will ease your life, right? And that will help you to avoid reading such a big kind of text. So and these are the three ones that will not go into details of those, but essentially generating argument, creating of timelines, and statute ingredients. So statute ingredients kind of needs some explanation because it's really like, do you have any one of you how many of you have like lawyers in their family? Anyone? Oh, nice. So you guys would be able to appreciate, like they catch you in words, right? Like, okay, this law is nice, just one sentence. Okay, section 420 of offense of cheating and dishonestly inducing delivery of property, right? But who will decide what's dishonesty? I'm inducing property in a given case or not, right? So they apply that rule to a given situation. Before application, it needs to understand that, okay, which are the key ingredients and what is their definition, right? So it becomes a key task that that we heard from folks that, okay, we want to, the LLM should be able to understand those. Okay, fine. So then we said that, okay, let's go on and create a data set that is really needed. And we saw that, okay, the range was anywhere from tens of thousands or 10K to 100K is what we are looking to create, right? So how do we go about creating this data? So we said that, okay, we did this as a part of OpenAI mission. And over past, we have been working on this mission for 3 years. And that mission really focuses on how do you enhance access to justice in India. As a part of that, we had over a period of time developed methods that can extract certain components from things like court judgment, FIRs, etc. So we use that. Hey, it's a good starting point. Let's extract whatever is possible. Let's say I take a court judgment. Court judgments, by the way, are available publicly. Some police FIRs can be scraped and available publicly, available for use. Laws definitely are available. So let's use those components and extract the ground truth where automatically, as far as possible, rather than me creating it synthetically. Although it sounds nice, that may not give you the best data. So we used wherever this extraction is possible and this data set could be created. In that way, we tried it. Wherever it is not possible, for example, argument generation, right? The arguments that are put forth by both of the parties to court is considered as a private information. It's not available publicly. Judgments are, but not the arguments and the backings and the facts and whatever evidences that they have provided. Right? So that's not available in public domain. So in that case, we had to fall back. Hey, can we use something like GPT-4o, saying that, okay, these are my issues, these are my arguments, this is the issue at hand, these are the laws. Can you put forward an argument for me? So we had to create this data synthetically wherever possible, right? And we followed certain guidelines that we believe could be used across multiple of the use cases, not just this one. And the first one is very important, that we want to teach an LLM reasoning and not recall, right? What's the difference, right? Reasoning is, okay, I have all the information that is needed to do the reasoning, but I don't have necessarily to make the model make it recall all the definitions of the laws, right? There is no need for it. I can retrieve this information, right? What I need to teach it is really focus on the reasoning and not the recall. So that's the important thing. Use real life situation, because if we use hypothetical situations, it becomes meaningless, right? And explain answers orca style. So this is an important thing that we learned. That how do LLMs think, right? So the LLMs think by spending output tokens, right? So more are the number of output tokens they generate, they are likely to generate better answers. We have seen this everywhere in self-reflection, and then reflection, you saw this hand, right? Like LLM is trying to, it's a similar thing, right? If I'm generating an output and asking the same LLM again to review this, it's likely that it will generate a better thing, right? So explanation of answers, just don't give me answers. Tell me why is this answer. That becomes an important thing while creating the data, right? And we discussed about synthetically generated answers only where it is unavoidable. Right? Then came the fine tuning aspect, which is the most fun thing. I, being a data scientist, I love this piece more, but there were so many steps that had to be taken before we reach here, right? So remember the first slide that I show you from Anand Kapati. This is the only piece. So there are 4 steps that we discussed: pre-training, supervised fine tuning, reward modeling, RL. We just did supervised fine tuning out of these 4. We started off with a Mistral 7 billion model. Why that? Because we wanted to use a model that was small enough that we could give to people and they can host it in-house, right? So if I do a fine tuning over a 70 billion parameter model, people will find it harder really to use, right? So we wanted to use something that is small enough, but can understand longer context. So at that point of time, Mistral 7 billion had 32K window, and also the licenses were permissive, right? We keep on saying that open source model, but it's really important to understand what's the true meaning of open source, right? When you take Llama model, you can use them for research purposes, but you can't take it fine tune and use it for commercial purposes. So we had to use a model that had a permissive license that we can actually use for commercial purposes, right? So it's important to factor to look at, right? And then we did fine tuning method using LoRa. So it's a piece of fine tuning technique under parameter efficient fine tuning. So LLMs have like billions of parameters, right? And then, like obviously, like when say billions of parameters, there are billions of numbers that we need to change, right? Can you change all of them? Maybe not, right? Which ones to choose is something that this metric tells us, right? So it's called as low rank adaptation. So you convert that large model matrix and you represent that with a smaller matrix, right? And then you change the weights on the smaller matrix and hope that it works better. So this is what something that we have used. It's very, very commonly used method. We used 32-bit full fine tuning using Hugging Face transformers, and the hardware and the cost, we could do this under $1,000 using 4 880G APUs. Again, like availability of this is again can be a challenging thing. So it's important to understand that when you do fine tuning, it's not just $1,000. You need to understand and get into a situation where you have access to these kind of GPUs. Right. And then we did so we went ahead and did all the fine tuning, and then we went ahead and say, okay, let's test how good or bad this model is doing. And we fell back to using LLM as a judge, right? I mean, tried 3 things. One of them is using GPT-4 as an evaluator, as compared to something like, okay, let's take a 3.5 turbo and see how Alap is doing, how good or bad it's doing. And what we found out, it's comparable. It's comparable performance to 3.5 turbo. So what you do is, okay, this is a task. This is a response that you get from Alap. This is a response for the same prompt you got from 3.5 turbo. And then you use GPT-4 as an evaluator, saying that, okay, which one do you prefer? Is it this one or that one, right? It will give you a binary answer. Sometimes like say, okay, both are comparable. And then we found out 3.5 and Alap are doing comparable on Alap test data, right? It's important to understand that this is a task that this is data that we created. I mean, there wasn't any data leakage, needless to say, but these are the kind of tasks on which I trained. And is Alap doing better? Yes, it's definitely doing better. And then we also did a study that, okay, if I use the same prompts on, let's say, Mistral 7 billion, that's our starting point. Are we doing any better? And we found out, yes. It's beating Mistral 7 billion in 85% of the cases. So yeah, I mean, it justifies on your data, it's really doing better. And a 7 billion parameter model is kind of doing a comparable performance to, let's say, at least 10 times bigger model, right? This is a common story that we hear. This is what we wanted to achieve. But what about on the data that we did not train off on, right? So there are publicly available data sets on which we can test, and these are legal bench. Legal bench is a kind of a benchmark data set, mostly in context of UK and Europe, wherein they kind of have created certain tasks, and you can do an evaluation. And AIB is all India bar exam, right? So it's more like a recall oriented exam where it's like you by heart the laws, right? They'll ask you a question, okay, tell me a definition of 420 of IPC. Is it A, B, C, or D? And then you'd, okay, no, this is the right answer. So it's by hearting of the laws and essentially the guidelines, right? So that's AIB. And what we found out there is on these kind of data sets where we haven't used, the model is actually not doing any better than Mistral 7 billion, and it's definitely doing worse than 3.5 turbo, right? So the hope was, if I take a data and I fine tuning it on that data, but if I take a related data set, the model may or may not give you a better performance, right? So documented limitations of fine tuning is loss of few shot abilities, right? So few shot abilities is essentially how do you you give some examples to model and ask it certain questions, right? And whether the model is able to do it, right? So these are the conclusions that, hey, these are the pitfalls of fine tuning. You do you well on given set of problems on which you have trained on, but if you go outside that boundary, it's not going to do well, right? So that's what we learned, right? Fine. Then the efforts of data creation. So this pie chart tells you how did we spend in this exercise, what kind of on what activities did we spend our effort on. And you see here, data creation took most of our time. And this is what we tell clients, say, look, when you want to do fine tuning, you should be willing to spend this much. 70% of time is being spent on definition of the task and data creation, right? And then just 30% is really doing the fine tuning and doing evaluations. And we did evaluation both, like we heard vibe checking, it's a new term, vibe checking, and objective evaluations. But yeah, that's an important piece to understand, that it's not easy to create tasks, and definitely not easy to create data sets. And then while we are doing fine tuning, we tried quantization, and that particular night I lost my sleep, because when you see this graph, what this graph is telling you is on a y-axis you have loss, and this is as your training progresses, is your model learning or not learning. This is what we tried using 4-bit quantized LoRa, and what this graph tells me is like the model is literally not learning anything. It's a shit. It's a piece of shit. When you show this to a data scientist, he'll say, what's going on? It's clearly something is wrong. Next day, we woke up and said that, hey, enough is enough. Okay, I need some more money, right? This fine-tuning business can't be done frugally. I need to burn some money. And then we said that, okay, no more quantization. We'll do 32-bit fine-tuning. And this is what we wanted to see. What this tells me really is that the model is able to learn with more training. And this is what you really wanted to see. The learning, quantization, while sounds exciting, may not give you what you want. So, yeah, another thing, if I want to redo all of this exercise today, would I be doing fine-tuning in first place? And honestly, the answer is maybe there are other ways to try rather than fine-tuning that will give you better results and better ROI in terms of what effort we spent. So focusing more on the data availability and searching is something that it's most critical than doing for better performance rather than doing fine-tunings, right? That's the hardest lesson that we learned out of all this, right? And we should have definitely not stopped at fine-tuning. There are ways we can go RL, and then that definitely improves the performance, specifically looking at the ethical aspects, doing adversarial training, something that we did not do, but I think that considering the criticality of the use case, that is something that we should have done. Focusing more on tool usage rather than just doing reasoning is another thing that we could have done. And focusing on the tasks with clearer evaluation metrics, right? When you have tasks like argument generation, it's your opinion versus my opinion, right? What's the real ground truth here? And when you have data like that, it can be hard for model to learn things, right? So focusing on tasks that have clearer ground truths and objective metrics can give you better performance, right? Okay, this is not the QR code for that quiz, okay? This is the QR code that will take you to the GitHub page of Alab. There is a paper there, there is the repo there, you get links to everywhere. So yeah, I know it's time for lunch also, but yeah, that's all from my side, folks. Thank you for your patience and open to